Hello students and welcome to this video. In this video we will solve question number 381 to 390 of Algebra, Permutations and Combinations chapter. The link to download the PDF will be in description. Also at the end I will show you how we can maintain versions of the downloaded PDF and how we can download the PDFs from the website. So stay tuned till the end for this video. Now with that out of the way, let's get started. Note that these are some involving problems you have to think, so pay attention, otherwise we will miss it. So without further ado, let's get started. Question 381 says that find the number of ways of arranging m numbers out of 1 through n so that maximum is n minus 2 and minimum is 2. Repetitions of numbers is allowed such that maximum and minimum both occur exactly once, n greater than 5 and m greater than 3. So we can choose maximum in m ways and minimum can be chosen in m minus ways or vice versa. Then we have n minus 5 numbers remaining, of which m minus 2 are to be chosen with repetition, which can be done in n minus 5 to the power m minus 2. Okay. So why we have n minus 5 numbers remaining? Because maximum is n minus 2 and minimum is 2. So we are leaving 2 numbers here and 1 number here, so that is 3. Then the minimum itself and the maximum itself, so that is 5. Okay. So the required answer is m multiplied by m minus 2 multiplied by n minus 5 to the power m minus 2. Question 382 says that 8 identical rooks are to be placed on an 8 by 8 chessboard. Find the number of ways of doing this so that no 2 rooks are in attacking position. Now to solve this problem you need to know how chess works, and if you don't know, you should learn how to play chess, because in your exams or in the course there can be questions on chessboard problems or topic. So you don't need to learn like a lot, basic stuff, how pieces move, that is all it is needed. So first rook can be placed in any square, that is 8 square ways. Now the second can be placed in 7 square and so on. So the rooks are identical. Okay. So number of ways is 8 factorial square by 8 factorial, that is 40,320. So you multiply all this 8 square, 7 square and all that till 1 square, you will get factorial 8 factorial squared. But 8 factorial came because rooks are identical. Question 383 says that define a good word as a sequence of letters that consists only of the letters A, B and C. Some of these letters may not appear in the sequence, in which A is never immediately followed by B, B is never immediately followed by C, and C is never immediately followed by A. How many 7-letter good words are there? So first position can be filled in 3 ways and rest in 2. Thus number of words is 3 multiplied by 2 to the power 6, that is 192. Question 384 says that 2 n-digit integers leading 0 allowed are said to be equivalent if one is a permutation of the other. Thus 10,075 and 1057 with leading 0 are equivalent. Find the number of 5-digit integers such that no 2 are equivalent. So the digits must be same and 2 numbers to be called equivalent. Since we have to find numbers which are not equivalent, we need to consider combinations and not permutations, because permutations will give equivalent numbers. When all digits are different, number of numbers is 10c5. When 3 digits are different and 2 digits are identical, number of numbers is 10c1 multiplied by 9c3. When 2 digits are different and 3 digits are identical, number of numbers is 10c1 multiplied by 9c2. There should 10C1 and 9C. Okay, yeah, two digits are identical, three are different. Okay. When four digits are identical and fifth is different, number of numbers is 10C1 multiplied by 9C1. When two pairs of two digits are identical and fifth is different, we have 10C1 multiplied by 9C1 multiplied by 8C1. When three digits are identical and two digits are also identical but a different digit, number of numbers is 10C1 multiplied by 9C1. Let me explain a bit here what is going on, okay? So, two digits are identical here and three are different. So the two identical digits can be chosen from 10 in 10C1 ways and three different digits can be chosen in 9C3 ways. When two digits are different and three are identical, the identical digits can be chosen in 10C1 ways. You can pick any digit from 1, 10. And two different means 9C2 and so on. Similarly, we have proceeded and adding these, you will get the desired answer. Question 385 says that if n distinct objects are arranged in a circle so that the number of ways of selecting three of these things so that no two of them are next to each other is n over 6 multiplied by n minus 4 multiplied by n minus 5. We let n objects be O1 through On. Total number of ways of selecting three objects so that no two of them are consecutive is total number of ways of selecting three objects minus number of ways of selecting three consecutive objects minus number of selecting three objects in which two are consecutive and one is separate. So first one is MC3. So three objective objects can be selected in the pattern O1, O2, O3, O2, O3, O4 and so on. So number of ways in which two consecutive objects can be selected is n. Next, we consider two consecutive objects and one separate. We can pick O1, O2 and third can be O4 to On. So there can be n pairs. So number of ways is n multiplied by n minus 4. So required number is MC3 minus n into n minus 4. So I'll explain a bit here, okay? So we pick O1, O2, okay? And third object can be from O4 to On minus 1. So how much is this? This is n minus 4 and O1, O2 can cycle like this example. Next would be O2, O3, then O3, O4 and it will continue till we come to On, O1. Okay, so there will be n such pairs. So that's how n into n minus 4. Question 386 says that there are 20 persons including two brothers. In how many ways can they be arranged on a round table if there is exactly one person between the two brothers? So we have 20 persons. So 18 persons can be arranged in 17 factorial ways. That is total number of ways. Now we seat two brothers around the person in two factorial ways. The brothers can exchange position. So that is two ways. Now that 18 persons are around in which two persons can be seated, thus total number of ways is 2 multiplied by 18 factorial. Next we have 387. Find the number of 18. Here this is not the correct. This is not the total number of ways. This is the number of ways in which 18 persons can be seated other than two brothers. Okay. Question 387 says that find the number of different ways of painting a cube by using a different color for each face from 6 available colors. Any two color schemes are called different if one cannot coincide with the other by a rotation of the cube. So a cube can be rotated into 6 multiplied by 4, 24 configurations. That is, one face can be any of the 6 and then there are 4 ways to rotate if that keeps the first face red or same. This should be same. So number of ways of painting the cube is 6 factorial multiplied by 26, that is 30. Question 388 says that find the number of ways in which n things of which are alike and the rest distinct can be arranged in a circle distinguishing between clockwise and anti-clockwise arrangement. n things can be arranged in circular fashion in n minus 1 factorial ways. However, are things alike or so like linear permutation, we have the required answer as is n minus 1 factorial over r factorial. Question 389 says that in how many ways can we divide 52 playing cards among 4 players equally in 4 parts equally? 54 cards among 4 players is a distribution problem, so from formula we have the answer as 52 factorial over 13 factorial to the power 4. 52 cards in a 4 groups is a division problem. The answer according to formula is 52 factorial by 13 factorial to the power 4 multiplied by 4 factorial. Question 390 says that 10 different toys are to be distributed among 10 children. Find the total number of ways of distributing these toys so that exactly 2 children do not get any toys. There are 2 mutually exclusive cases. In first case, 2 children get none. Then 1 child gets 3 and remaining get 1 each. In second case, 2 children get none, 2 gets 2 toys and remaining get 1 each. In the first case, number of ways is 10 factorial divided by 2 factorial multiplied by 3 factorial multiplied by 7 factorial into 10 factorial. And in the second case, it is 10 factorial divided by 2 factorial multiplied by 2 factorial square multiplied by 2 factorial multiplied by 6 factorial. And then in the numerator, you multiply with 10 factorial again. So with this, we come to the end of 39th set of the questions. Now I will show you how you can download the book. You can download the books from my website ashtavakra.org. Okay, what happened? Okay, so you have algebra, trigonometry and coordinate geometry books. So you observe the date here. The first 4 is year, then we have month, then we have day. Okay, when you download, it will not have the date, so you should add date. And when the date changes, you can download it again. Okay, you probably every 15 days you can come to the website and click download and you can see. Now the thing is that I cannot put date in the file name itself because my YouTube links, I will have to update every time all the links whenever the date changes, which is basically too difficult or practically not feasible for me. So with this, I will end the video here. I hope you are enjoying this series of videos or the entire playlist, useful and informative. So we will meet again tomorrow with 10 more problems. I thank you for watching the video and keep practicing. I'll see you in the next one. Till then, take care and enjoy.